Today we talk about differentiation, how to use the derivative to determine the functions, the nature. So uh, for this function, y equal to fx, for some point, this is the first derivative is the equal fx prime equal to 0. How to determine the nature of this point? We can use the second derivatives to determine. So we first see that for the maximum point, this is the fx, the first derivative equal to 0. This is the stationary point. For the gradient, this part is the positive. This part is the negative. So this one is the concave down. So this gradient is the second derivatives is the less than 0. So this is the maximum point. For the minimum point, the stationary point is the first derivative equal to 0. For this part, is the gradient is the negative. This is the gradient is positive. So the second derivatives is the more than 0. This is the minimum point. Minimum. This part is the concave up, concave down. We can determine the point is the maximum or the minimum point. For the stationary point of the inflections, we can see that the gradient is the positive. This also the positive. So the first gradient equal to 0. For the gradient, this part, the gradient from positive to 0, then to the positive again. We can see that for the function, the curve, this part curve is the concave down. This part is concave up. So this one is the gradient is always the positive to 0, then to positive. This is the inflection point. For this part, the gradient is the negative. This is also the negative. This is also the inflection point. This is the concave up. For this part of curve is the concave down. So we can gradient this gradient change from positive to 0, then to positive again. This is the gradient. Positive to 0, then positive. This curve is gradient. Negative to 0, then negative. This is the inflection point. Inflection point. Now see the example. Find the coordinates of the stationary point. Stationary point for the function, for this function, using the second derivative to determine the nature of this point. We can see that the first derivative equal to 0, we can find the point A and B. For the A, this part is the -1, 2. This B is the 1, -2. This 2 point. For the second derivative, for point A, is the second derivative is the less than 0. So this is the maximum point. For the point B, the second derivative is the more than 0. So this is the minimum point. For this part is the concave dot. This part is the concave up. So we can decide the point A is the maximum point. Point B is the minimum point. We can see the second example. Find the coordinate of the stationary point for this function. We can use the first derivative equal to 0, find the point at our original 0, 0. For this point, the second derivative equal to 0. For this part, the gradient is positive. This part is the gradient positive. So the gradient is positive to 0, then to positive again. Positive again. So this point point 0, 0 is a horizontal point. Inflection point. Now we see that the point is the example 3. Find the coordinate of stationary point for the function. We can see that for the first derivative equal to 0, find the point 1, and this also the A, B. This point is the minus 1, 2. This is the 1 minus 2. Now we see that for the point at the original, this point is the, for the second derivatives, the at this point equal to 0. The second derivative equal to 0. We can see that the gradient for this part is the minus minus, then this one is minus minus. So the gradient is the from the negative to 0 to negative negative. So this part, the point A, point O is the point of inflections. This is the have the for at this part have the concavity change. This is the concave down. This is the concave up. So this point is the point of the inflections. So now we give a summary for this part. For this part, we can determine the point of the point nature using the first derivative and the second derivative. For first derivative equal to 0 is the stationary point. We can further use the second derivatives to determine the nature of the stationary point. For the first derivative equal to 0, then the second derivative the more than 0 is the minimum point. For the first derivative equal to 0, second derivative less than 0 is the maximum point. If the second derivative equal to 0 is a possible horizontal point of the inflections. For the second derivative equal to 0, a point of inflection marks a change in the sign of the concavity is the from, for example, from the concave down change to concave up. Okay, this is for today's topic about differentiation, how to use the second derivatives to determine the nature of the stationary point. Okay, thank you for watching.